Day 146, Physics Homework Circuits Problem number 1B. Once again, we need to simplify this circuit. There is no rule that says you start with the parallel portion or the series portion. This is a combination of series and parallel. It comes with practice, knowing where to start. This one you could actually start in two different spots. You could start by combining the 20 and the 30. I can actually do this in one step. The 20 and the 30 together are in series. If I'm at this location right here, actually the current's probably going to flow around this way in this case, because this is the long side or the positive part of the battery. So the current's going to flow around counterclockwise. The current will come down here and split. Some current will go this way. Some current will come down this way and go back to the battery in this counterclockwise fashion. But at this spot, if you go from here over to there, the flow of the electrons, or current, electrons are actually going the opposite direction, but that's okay. It doesn't really matter which way you're going, from here to here or from here to there. Either way, these two are in series. They're one pathway, so that's going to be 50 ohms. If I come down around this way, though, and go this way and get this spot, I have two ways to get to that spot. I can go up and around, or I can go down and around. These two are in parallel. So I'm going to look at the 50 and the 60 in parallel and do the math for that. I'll write it down. It's 1 over R sub t total equals 1 over 50 plus 1 over 60. So the total is 27 ohms. So I actually am going to do two steps in one here. I'm going to draw the new diagram replacing the 50 and the 60 with that 27 ohms, and I'm going to replace the 20 and the 30 with a 50. So I've drawn the new diagram. The 20 and the 30 are in series. Simply 20 plus 30 is 50. And then I showed the math to combine the 50 and the 60. They become a 27. So I replace that parallel portion of the circuit with this single 27 ohm resistor. Sometimes it's not good to do two steps in one, but here it was easy enough to do it, so I did it. All right, so now, once again, if I have current flowing, which will flow around this way, the current gets to this spot. It has two pathways. It has this pathway to get across or come down and around this way, but these are in series. They're in a single branch, so that's going to be a simple 40 plus 27 is 67 ohms. I'll draw that diagram. So I've drawn that diagram. It's still a 100-volt battery. It should be fairly obvious now that the 50 and the 67 are in parallel with each other, so I need to combine them by 1 over their total resistance equals 1 over 50 plus 1 over 67. Pause this, calculate that. Comes out to be 29 ohms. Similar to previous one, because previously it was a 50 and a 60. Now I have a 50 and a 67. But that's my actually overall final answer for the total resistance. I can draw my diagram. I'll draw it down here. There's a single resistor, a 29 ohm resistor with a 100 volt battery. So way up in the top, my total resistance is 29 ohms. These diagrams are very important. I'll be grading these diagrams on a test. And then down here on the bottom right, I'm going to use V equals IR for this final diagram to get my overall current. I have 100 equals I times 29. That's a 29. So I, once again, is around 3 amps. It's 100 divided by 29, 3.4. to 2 sig figs, 3.4 amps. That's my current. That's all I need to do in this problem. Filling in a blank up at the top there. But once again, just a little further information. Down here in the bottom right, that's 3.4 amps. So up on the upper right here, the battery is pushing 3.4 amps. 3.4 amps gets there, and once again, a little bit more than half goes this way, because that's an easier pathway, not much easier, and a little bit less than half goes this way. So this is roughly going to be half of 3.4, less than 3, maybe 1.5 amps. And this will be then 1.9 amps. something like that, two values that add up to 3.4 amps of total current that then joins back together right here and is pushed around by the battery.